Dear students, following question is a question from topic of hydraulic machinery, where it is asked that if some data pertaining to pressure and velocity characteristic of a turbine is given and no external losses are occurring and entire head is getting converted to power, what will be the power produced by turbine? Now, since energy is conserved, the energy at inlet has to be equal to energy at outlet plus the energy that is produced, that is E1 plus energy that is or power that is produced by turbine. Now we will be calculating the energy in terms of heads that we call as specific energy. So Q is given as 0.1 m cube per second. Energy at inlet or head at inlet, I will say, is P1 upon, I'll write it as H1, P1 upon rho g plus V1 square by 2g. Pressure is given, velocity is given at inlet as 3 into 10 to the power 5 Newton per meter square, and velocity is given as 100 meter per second. Both are in SI units, so no issues. And energy at outlet, pressure is given at outlet as 1 into 10 to the power 5 and velocity at outlet is given as 50 meter second, and the difference between these two heads, that is H1 and H2, is entirely converted into power because no losses are taken place. So head that is utilized in production of energy is definitely E2 minus E1 or H2 minus H1. So H2 is calculated here, H1 is calculated from equation number 1, H2 from equation number 2. So just by subtracting 2 from 1 from 2, change in head comes out as 402.64 meter, and power produced because of loss of this much head is rho into G into H2 into Q. Now Q is given as 0.1 meter cube per second because it is given as 100 liter per second, which is definitely 0.1 m cube per second, into 402.64 meter is head loss, into rho g, which is 9810, to obtain answer in kilowatt, which comes out as 395 kilowatt, making answer lying in the range of 390 and 400, since it is a numerical response type question. Thank you.